In the last video, we covered the Solidify option in Edit Mode's Face menu. And the Solidify modifier does essentially the same job, but with several more parameters that gives us greater control over the final result. And of course, like all modifiers, the effect it creates can easily be reversed by deleting the modifier. To keep things simple, we'll start with a cube with its top face removed and then add a Solidify modifier. Now, rather than work our way through the parameter options in the order in which they appear, we'll start with the simplest to understand. Thickness sets the thickness added to all the faces in the object. A positive value adds the thickness to one side of the existing faces, while a negative value adds them to the other side. We'll call the original set of faces the first or inner shell, and the newly created ones the second or outer shell. Normally, the thickness should be the same on all the faces. However, if we've changed the shape of our primitive as we have here, we might find that the thickness varies. And this is because we've forgotten to apply the change in scale. As soon as we correct this oversight, the thickness becomes uniform. The next field is Offset. This determines the direction of the thickness. The default value of -1 causes the thickness to be added on the back face. That, of course, assumes that thickness has a positive value. When Offset is set to +1, thickness is added to the front face. Values in between add a percentage of the thickness to both sides, with 0 adding equally to both sides. To explain even thickness, we start with two faces at right angles to each other. When we add the Solidify modifier and adjust the thickness, we'll see that the thickness isn't consistent. The reason for this is that Simple Mode's default is to create the new vertices of the second shell at an equal distance from the existing vertices along the direction of the face normals. However, when a vertex is shared by more than one face, the direction is the average of the face normals. In our example here, that means that the corner vertices extend diagonally. So, in our object, although the new vertices are an equal distance from the old original ones, we don't get the uniform thickness we want. But, if we check even thickness, Blender ensures that the thickness is constant. Rim, if checked, displays the added faces between the inner and outer shells of our new shape. If we deselect this, we create a gap between the first and second shells. With Rim selected, we have the option to select only Rim, which displays only the connection between the first and second shells, but not the second shell itself. Now, let's go back to Mode. The default value is Simple, and for most geometries this will be sufficient. However, there are specific situations where we won't get the result we're hoping for when using this setting. But changing to the Mode setting of Complex can solve most problems. However, for the moment, let's stick with our current simple shape. Notice that when we selected Complex, two new fields appear in the Modifiers panel. Thickness Mode has three possible settings: Fixed, Even, and Constraints. Fixed is really no different from using Simple Mode with its default settings. Even is the equivalent of Simple Mode with the Even Thickness option checked. However, it can produce the result we want in geometries that would fail when using Simple Mode. For example, here we have a single edge connected to three faces. When we try to use Simple and Even Thickness, the result is still off. But if we use Complex and Even, we get the result we're after. Boundary. When our original object has a hole in its geometry, the options here give us different ways of dealing with it. We'll cover each of the three options using half a UV sphere with a hole in its surface. As we change between each boundary option, None, Round, and Flat, we can see that there are slight changes in the faces of the second shell near the hole. It's simply a matter of choosing which option suits your needs in any given situation. The next new field when using complex mode is Merge Threshold, which allows us to merge nearby vertices. How near each other the vertices must be is determined by the value given here. There won't be many situations where you're going to find this useful. The nature of the Only Rim checkbox also changes when we are using complex mode. Now, when we check this option, both the first and second shells are removed, leaving, as the label suggests, only the rim. Next, we come to Vertex Group. If we select a vertex group in this field, the vertex weights assigned to the individual vertices in that group can be used to affect the actual thickness created by the Solidify modifier. To demonstrate, we'll start with a grid with one X subdivision and 6 Y subdivisions. Now we'll put all but 2 of its vertices into a vertex group, and then assign each pair in the group a different vertex weight, starting at 0, using increments of 0.2. After adding a Solidify modifier, which we'll leave in the default Simple mode, since what follows is not mode-dependent, we'll set the thickness to 1 meter and the offset to 1 so that the second shell grows from the front face. Next, we'll select our vertex group and jump to right side view. Now we can see the result of the operation more clearly. The thickness value is multiplied by the vertex weight to give the actual thickness applied. For example, where the vertex weight is 0, we get a thickness of 0. Where the weight is 0.2, we get a thickness of 20 centimeters. Note that the vertices outside the named group are assumed to have a vertex weight of 0, irrespective of their actual weight. To the right of the vertex group field is the Invert button. This changes the weight values used to the complement of their actual value. For example, where the weight was 0.2, it is changed for the purpose of the calculation to 0.8. In other words, when the Invert button is pressed, the weight value is calculated as 1 minus the actual weight value. The Factor field is a percentage multiplier used to fill in the gap between the potential 1 meter thickness and the actual thickness. With a value of 0, the gap is unchanged. With a factor value of 0.5, 50% of the gap is filled, and at 1.0, the gap is completely filled, meaning we have a thickness of 1 meter across the whole plane. If we select a vertex group while using complex mode, an additional checkbox labeled Flat Faces appears. According to the manual, when this is selected, it adjusts the vertex weights so that the faces in the second shell remain parallel to those in the first shell. As you can see, that's not what happens. Instead, non-zero vertices seem to be assigned the weights based on some unknown formula. Moving on, there are 2 options under the heading Normals. Flip, when checked, flips the normals of all faces. In general, the modifier already makes a good job of ensuring the new faces are correctly orientated. And if you do have to flip the normals on some faces, a better option is to use the Recalculate Outside option under Normals in Edit Mode's Mesh menu. High Quality only appears when using Simple mode. The manual states that this option can adjust normals to achieve a more even thickness when used on some geometries. Materials is the next heading. To show the options available here, we'll start with an open cube and assign different materials to each side. The basic ideas behind adding a material was covered in video 24. However, here we're going a little further by assigning several materials to a single object and then placing each of those materials on a different side of the cube. Blender uses the value in the Material Offset field to determine which material should be assigned to each of the new faces created by the Solidify modifier. The default value is 0, and this assigns the new faces of the inner shell the same material as the equivalent face on the outer shell. If we change this to 1, the face on the inner shell uses the material 1 removed from the original material as determined by the material list. Looking at that list, we can see that yellow is the next material after red. So where the face on the outer shell is red, the face on the inner shell is yellow. Yellow outer creates a blue inner. Blue outer gives green inner. But when we start with a green outer, there are no more materials, so the inner face remains green. Changing material offset to 2 means the inner face is 2 materials along the list from the one on the outer shell. Since we can go no further than green, we eventually end up with all the inner faces being green. The rim field follows the same rules for the material used of the new rim faces. Both fields can also be given negative values. This moves the material selection in the opposite direction along the list stopping at red. Edge data is another heading whose content changes depending on which mode we are working in. Using simple mode, there are 4 fields. The first 3, crease inner, outer, and rim, set the edges in each of those areas as crease edges, the value given here being the crease weight. Crease edges are used to control the shape formed when using the subdivision surface modifier. So these settings are only useful if we intend to add that modifier to our current object. The fourth field, bevel convex, and the only one to appear when using complex mode, can be used to assign a bevel weight to the edges that connect exclusively to the original faces on the first shell. To demonstrate the next parameter in the Solidify Modifiers panel, we'll start with a cube, delete 4 of its sides, and bevel the common edge. Now, when we apply the Solidify modifier and increase the thickness, all seems well. But if we display the construct using wireframe, we can see that if we take the thickness too far, the edges around the bevel cross over each other. This is a geometry that will cause problems in later stages of our design. The thickness clamp options are there to offer a solution to this type of problem. Clamp sets the maximum thickness in the problem area. Check Angle Clamp if you want to base the maximum thickness on the angle created. The final parameters are under the heading Output Vertex Groups. Here we can add all the vertices that are part of the second shell, and all the vertices used in the rim to existing vertex groups. Of course, this only has purpose if we intend to apply the Solidify modifier. These two groups will have several vertices in common.